So now, well, this is true for any changes in x, y, z, but in particular, let's look at the changes that we get if we just take these formulas as functions of time and change time a little bit by delta t. Okay, so we'll actually use the changes in x, y, z in a small time delta t. And let's divide everybody by delta t. Okay, here I'm just dividing numbers, so I'm not actually playing any tricks on you. I mean, we don't really know what it means to divide differentials, but dividing numbers is something we know. And now, if I take delta t very small, then this guy tends to the differential. Sorry, tends to the derivative, df dt. Remember, the definition of df dt is the limit of this ratio when the time interval delta t tends to 0. So that means if I get, if I choose smaller and smaller values of delta t, then these ratios of numbers will actually tend to some value, and that value is the derivative. So similarly, here, delta x over delta t, when delta t is really small, will tend to the derivative dx dt. And similarly for the others. So, okay, so that means, in particular, so if we take the limit as delta t tends to 0, we get df dt on one side. On the other side, we get f sub x dx dt plus f sub y dy dt plus f sub z dz dt. And the approximation becomes better and better. Remember, when we write approximately equal, that means that it's not quite the same, but if we take smaller and smaller variations, then actually we'll end up with values that are getting closer and closer. So when we take the limit as delta t tends to 0, eventually we get an equality. I mean, mathematicians have more complicated words to justify this statement, but I will spare them for now, and you will see about them when you take analysis, if you go on in that direction. Okay, any questions so far? No? Okay, so let's check maybe things on an example. Let's say that we really don't have any faith in these things. And so let's try to do it. So let's say I give you a function that's x squared y plus z, and let's say that maybe x will be t, y will be e to the t, and z will be sine t. So what does the chain rule say? Well, the chain rule tells us that dw dt is, so we start with partial w over partial x. Well, what is that? That's 2xy times, so maybe I should point out this is w sub x, times dx dt plus Well, w sub y is x squared times dy dt plus w sub z, that's going to be just 1 dz dt. Okay? And so now let's plug in the actual values of these things. So x is t, y is e to the t, so that will be 2t e to the t. Dx dt is 1 plus x squared is t squared. Dy dt is e to the t plus dz dt is cosine t. Okay, so at the end of calculation we get 2t e to the t plus t squared e to the t plus cosine t. That's what the chain rule tells us. How else could we find that? Well, we could just plug in values of x, y, and z, express w as a function of t, and take its derivative. Okay? Let's do that just for verification. It should be exactly the same answer. And in fact, in this case, the two calculations are roughly equal in complication. But say that your function of x, y, z was much more complicated than that, or maybe you actually didn't know a formula for it, you only knew its partial derivatives, then you would need to use the chain rule. So sometimes plugging in values is easier, but not always. So let's just check quickly. So the other method would be to substitute. So w as a function of t. Well, so remember w was it x squared y plus z. So as a function of t, well, x was t, so you get t squared, y is e to the t, plus z was sine t. So dw dt, we know how to take the derivative using single variable calculus. Well, we should know. If we don't know, then we should take a look at 1801 again. So by the product rule, that will be derivative of t squared is 2t times e to the t plus t squared times the derivative of e to the t is e to the t plus cosine t. Okay? And that's the same answer as over there. So I ended up writing up, maybe I wrote slightly more here, but actually the amount of calculations really was pretty much the same. Okay, any questions about that? Yes? What kind of object is W? So, well, I was intending, you can think of W as just another variable that's given as a function of x, y, and z, for example. So you have a function of x, y, z defined by this formula.